So we're going to continue where we left off after our Google Meet. I do want to say at the beginning, if you don't learn as well from videos, you can join my class by Google Meet each day that you're not here instead of watching this video. But if you've already missed class, you need to watch the video. So I'm going to pick up on page 10 in your packet. If you notice at the top of page 10, they did the prime factorization method like we've been doing, which I call the singles mingle, but it's really prime factorization. And they kind of show you how that works in example 1. Don't look at example 2 yet because we're not getting to that type yet. So there is an example there you can look at, but let's go down to number 1. Now, as you can see, there is not a lot of room on this paper. So I have got out another sheet of paper. So if you need to grab one, pause the video real quick. But let's look at the directions. It says simplify the expression. You remember those blanks we filled in at the top of the page? The first one says that it can't be divisible by any perfect squares other than 1 under the radicand or under the square root, under the radical. The 28 is the radicand. This is the radical symbol. So we're trying to find any perfect squares that go into this. So I'm going to keep showing you both methods for a couple of examples, and then I'll probably stick with one. So the method that we don't use as often but works is to find a perfect square that goes into 28. So if I look at 28, I always start with dividing it by 2. 14 is the largest number that goes into 28 evenly. So I try the perfect squares under that. So the first perfect square under 14 is 9, and 9 will not go into 28. After 9 is 4. 4 will go into 28. So I could break this up into the square root of 4 times 7, because 4 times 7 is 28. And then that rule says if two things multiply to give you that you can break it up into 2 separate square roots. And the square root of 4 is 2. So this becomes 2 square roots of 7. 7 is a prime number, so we know we are done. There are no perfect squares that go into 7. But what if you like the singles mingle method better? If you like the singles mingle method better, you would start by making the factor tree. So I would do maybe 2 and 14, and then 2 and 7. So under the square root, I put the prime factors, 2 times 2 times 7. And I say, okay, did anybody find a match at the singles mingle? And yes, the 2's found a match. So 2 times 2 is 4, and the square root of 4 is 2. So that's why the 2 goes out front as 1. Remember, now they can file their taxes together as just 1, so they only have to write it down one time. And the 7 is left on its own. And that's it. So now let's look at number 2. Number 2 is the square root of 68. So I could do the perfect squares method, and I say, okay, what's 68 divided by 2? That's 34. So I'm going to try every perfect square that's under 34. So the first one that's under 34 is 25. If you don't know these by heart, remember you can go to this list. There's 36. I'm looking for anything under 34. So I got to try these 4 right here. And if these 4 work, then I will use one of them. So 68 divided by 25, which I know doesn't work. 68 divided by 16, that doesn't work. 68 divided by 9, that doesn't work. 68 divided by 4, and that does work. So, okay, square root of 4 times 17, because 4 times 17 is 68. So that's the square root of 4, and the square root of 17. So the square root of 4 is 2. You can stick with this method. You do not have to do both methods. I'm continuing to do both methods for all students. That way, if you like one better than the other, you can see your method. So here's 68. So I'm going to break that up. I would do this as 2 and 34 because it's even. I know it's divisible by 2. And then I do it as 2 and 17. 17 is a prime number, so we stop. Put them at the singles mingle. 2 times 2 times 17. 2 goes out front because they found a match. 17 stuck at the singles mingle by himself. All right, so that is on page 10. Let's look at one more on page 10 before I stop this video. Let's go to number 5, square root of 162. Now I'm going to kind of go with the singles mingle method. If you like the other method and you want to see me do this, I can send a picture to you of you with the other method, but I'm going to start by the factor tree. Well, I don't know a lot of things that go into 162, but it's even, so I know 2 will go into it. So I start with 2, and that is 81. Hey, I can see right there, 81 is a perfect square. So if you were doing the other method, you can already know that there. But 81 is 9 times 9. 9 is 3 times 3. So when I write these from least to greatest, there's 1, 2, and 4 3s. 2 does not have a match, so he has to stay at the singles mingle. 3 times 3 is 9, and 3 times 3 is 9. So those 2 3s go out front as a pair. So now that's these 2 become 1, and these 2 become 1. And the 2 is left under there. So 3 times 3 is 9, and 9 squared is 2. Now, because I did quickly see 81 there, if you wanted to do it the other way, perfect squares that go into it would be 81 times 2, because 162 is 81 times 2. So that's the square root of 81 times the square root of 2, and the square root of 81 is 9. So either way, you get the same answer. Now, we're going to learn how to multiply these things. We're going to learn how to do this with variables, but I'm going to do that in a different video. For now, I want you to get off of this video, and I want you to go do the con. The first one I've assigned you on just simplifying radicals. I've got the name of it there for you. Please only do that one, because the other one has some variables, and I haven't taught you what to do with variables yet.